Thank you. I'm glad you guys appreciate this. Love this class. Don't hold me to that. All right. Okay. All right. So there's a few topics from chapter 12. They're just kind of like I shouldn't make too light of this chapter, okay? Because it is an important chapter. It's just there's not a whole lot of calculations involved, okay? So the students like that, but then some students also hate it because there's no calculations and you kind of have to. It's a little bit more reading and stuff like that, okay?
Was that part of chapter 12 also?
No, this was all review of hypothesis testing and confidence intervals and all that good stuff, okay? All right, so now I want to talk about sampling, okay? Sampling methods, okay? And there is one sampling method that we've talked about quite a bit, and what is that? Simple random sampling, right? Simple random sampling. SRS. And how does simple random sampling work?
Random.
It's random, right? What does it require that actually makes simple random sampling different?
Drawing names out of a hat?
Yeah, drawing names out of a hat, or it requires us to know all the names to put into the hat, right? It requires us to know every single person in the population. Simple random sampling requires basically a list. So we need a list of everyone in the population. And we can draw from that list at random. We draw individuals at random from that list. This is very difficult to do unless you're at some institution or an organization where you have a list of everyone. So if you're at if you want to sample employees from a company, you can probably do that because you can go to the HR department and get a list of everyone on payroll, okay? If they'll give that to you, okay? Or if you want to sample students from UCLA, you can probably go to the, administration office, and they probably won't release it to you, but they've got a list of all the students enrolled in all their classes. Okay, so you have a list of everyone. But if you move anything beyond that, like the County of Los Angeles, we don't have a list of every single person in the County of Los Angeles. Okay, or the United States, we don't have a list of every single person in the United States. So simple random sampling becomes very, very challenging or almost impossible to do whenever a list of everyone does not exist. Okay, so SRS is almost impossible for situations where this list does not exist. So there's a few other methods that we can use, okay? One is cluster sampling. Okay.
Would this be alternatives?
Yeah, these are alternatives to simple random sampling that will give you a sample that's close to random, okay? So one of our conditions and assumptions for all of these hypothesis tests is what? The random and independent, right? We got random and independent, big population, large sample. Those are our three conditions that we generally have to check. So when we say random independent, we're usually saying we got simple random sampling. Okay, if that's not possible, sometimes we have to turn to these alternatives that give us, almost as good of a sample. Maybe not as good, but almost as good. Okay. So cluster sampling. This says our population is divided into subgroups. Okay. And here's the key. Our subgroups, we have a list of all the subgroups. These are basically it's divided. The population is divided into groups. Okay, all right. The subgroups are called clusters, by the way. Okay, that's why we call these cluster sampling. Okay, the subgroups are clusters. Okay, and I guess another key thing is. Within each subgroup, there should be kind of a variety. There should be some variation within the subgroups. So there should be, the subgroups should not be homogeneous, I should say. How do I say this? Okay. So within the subgroups, some diversity exists. Okay. And then, and so what we do is since we have a list of all the subgroups, we randomly select subgroups from that list. Okay, so we randomly select some of the clusters. Once we've selected those clusters, then we either survey everybody in each cluster or we perform simple random sampling within the cluster. Once we have selected the clusters, we either survey everyone in the cluster, or perform SRS within the clusters. Okay, so here's an example. I'm sorry? So let me give you an example of cluster sampling. Okay, let's say we wanted to get a random sample of everyone who attends church. Okay, that would be very difficult to do. Okay, everyone who attends, let's just say Los Angeles County. Let's say we want to get a random sample of everyone who attends church in Los Angeles County. Okay, practically impossible. Why? Because simple random sampling requires a list of everyone that attends church, and we probably don't have that anywhere. Okay. So what cluster sampling says is that, okay, you know what? I don't have a list of everyone that attends church. What I do have though is I have a list of all the churches in Los Angeles County. Okay, so we can obtain that, right? We go online and we say churches in LA area or whatever. We can get a list of all the churches in Los Angeles County. So whatever, there's a few hundred churches. So we randomly select some of the churches from that list. Okay, so maybe I've randomly picked 10 of these churches, and then I go to those 10 churches, and then once I go there, I can either perform simple random sampling at the church, or I can interview everyone at the church. Okay, I can either select everyone who goes to that church to be part of the sample, or I could say, do you have a list of all of your members? Probably the churches will have a list of all of their members, and then I can perform simple random sampling from their list. But it doesn't require me to have a list of everyone who goes to church, which is too hard to get. I just have a list of all the churches. I randomly select from that list some of the churches, and then I go to those churches and then select people to be part of the sample. Okay. So let's say we want to sample churchgoers in LA. Okay. So a complete list does not exist. So we cannot do simple random SRS. Okay. So instead, I make a list of all the churches. So here, this would be our list of clusters. Randomly select some of the churches. And then survey everyone at each church, or perform simple random sampling at the churches. At each of the selected churches. Okay, so that's cluster sampling. So that sometimes works as an alternative to simple random sampling. Okay, the other is stratified sampling. Stratified sampling also divides our population into subgroups, but is very different from cluster sampling. Okay? So our population into subgroups, and here our subgroups are called strata. And the members of each strata all share some common trait. Okay? Okay? So we can have strata where men and women, okay? Those are two strata. Because all the men share a common trait in that they're all men, and then all the women, they all share a common trait in that they're women, okay? Or you could divide the population into strata based on race, okay? And one race, and another race, and another race. They're all different, but they all share, the members of each strata share something in common, okay? Or you can do it by age group or whatever. Okay, so you've divided the population into strata, and the members of each strata share a common trait. And then what you do is you randomly select members from each strata so that the proportions in the sample match the proportions in the population. Okay? So if the population is 50% male and 50% female, you randomly select males and randomly select females so that 50% of your sample is male and 50% of your sample is female. Okay? If the population is, let's say 30% white and some other percentage of another ethnicity or whatever, okay, you pick your sample so that 30% of your sample is white, so it matches the proportion that exists in the population. Okay? So you select from each strata so that the proportions match the proportion of the population. Does that make sense?
Yes.
Okay. That's stratified sampling. Okay. And then lastly, we have systematic sampling. This works best whenever we have a line or a, here, just put it on the table there. So whenever we've got a line or something, in here we would say we're going to stop every 10th person in the line to be part of my sample, okay? Or every 4th person in the line to be part of my sample, okay? That's systematic sampling, okay? So it works best for a line, okay, or queue. This word is so weird. It's just like the letters keep going. Okay, and it's like pick every 10th person to be in the sample. Okay. Or any other number. Systematic sampling. Okay. So on the final exam, it's also on the practice final exam. There's a little section where I describe a scenario, or describe a scenario where some sampling method is employed, and you've got to identify is it simple random, or systematic, or cluster, or stratified. Okay? Yes?
So the systematic, that could work for a letter in the person's last name, or
no, it's...
it has to be a number?
No, it's you've got a line, right? So sometimes when you go to the drive-through at Jack in the Box, right? They say you've been selected to I don't know.
Be in a survey.
Be in a survey, right? And then call back and we'll give you a free taco or something. Right. Sometimes you get the survey, sometimes you don't. Okay. And I think with Jack in the Box it says like every 3rd or every 4th person that goes through the line gets that little phone number and thing on their receipt. Okay. Or what else is that? They might maybe at a toll bridge. Okay,
so
when people are passing through, they might stop every 10th car and write down whatever the color of the car or something. Try to get
but
an
in
idea.
order for something to be systematic, I guess my question is, there has to be a number involved.
There has to be a line or some kind of queue of things going through. Okay, your population has to funnel through some kind of queue, and then you're saying I'm going to pick every 10th person or every 5th person or whatever. That's a systematic sample. So yes, there's a number, and that's how you're choosing who's going to be part of the sample. Maybe I don't fully understand your question.
No, I think it is.
Okay, so
but it couldn't be based on any other thing, but which number, selected number is coming through a queue.
Yeah. So I mean, so
So
if
it can't be
TSA
by
wanted to
race,
say,
it can't
at the airport, because they got a queue, they could say, oh, we're going to stop every 10th person for extra whatever, searching or whatever. But that's not what they do, right? They say it's random, right?
Right.
You've been selected for random screening, but it's not really a random screening.
Right.
So, but if they want to be truly transparent and it would truly be random screening and everybody would be completely fair and think this was fair, is they would just have to put in a little. They would have a die, right? You roll a die. If it comes up on the number 6, you have to do extra screening, okay? Or something like that. That would be a simple process. Nobody would say this is unfair, and they would go along with it, okay? But everybody knows that
Profile.
that they use other things to decide who gets selected for screening. So, okay. Well, you know what? There's a couple more things in chapter 12 that are in your homework for reading, okay? Read the textbook and make sure you understand, and then we'll let you guys go early today, all right?